Okay, this is standard algorithm for multiplying fractions. Standard algorithm for multiplying fractions seems to be the one that's easiest for me, but you can decide for your own. So 3/4 times 2, I don't know, thirds. So for multiplying fractions, all you're going to do, take the top number, multiply across, take the bottom number, multiply across. 3 times 2 gives me 6. Let me switch colors, because that's just who I am as a person. Gives me 6. 4 times 3 is 12. Can this be simplified? Yes, it can. 6 divided by 6 gives us 1. 12 divided by is 2. So this can be simplified to 1/2. We can do another one. So as long as your kids know basic multiplication facts, they should be able to, let's do a weird one, 12/4 times 12, let's not do that one, 2/4. Okay, so even if the denominator is the same, so for subtraction and addition of fractions, the denominator for standard algorithm needs to be the same in order for you to work the problem. That is not the case in multiplication. It might make it slightly easier because people know their doubles better. But otherwise, it makes no difference. 12 times 2 gives us 24. 4 times 4 gives us 16. Excuse me. So this can be further broken down. And I'm going to do it the long way just to show how to simplify a fraction, just in case we need to do that. So 24, I know, can be divided by 2, and I know 16 can be divided by 2 as well. So that gives me 12. 16 divided by 2 gives me 8. Each of these can be divided by 2 again. 12 divided by 2 gives me 6. 8 divided by 2 gives me 4. They can be divided by 2 again. 6 divided by 2. 6 divided by, I got an equal, okay. 6 divided by 2 gives me 3. 4 divided by 2 gives me 2. So this is the same as 3/2, or if you've gone over mixed numbers, you know that's 1 and 1/2. Because if you have 3/2, that means you have 2 halves, which is 1, plus 1 left over. This doesn't make sense, but, plus 1/2. Okay, so why does standard algorithm work? I'm going to draw a picture to try to explain it a little bit better, because I work best with pictures. So when you read this, a great way to read this is 1/2 of 1/4. And I should probably be consistent and write out 1. 1/2 of 1/4. So the way you can do that, I'm going to divide my box into fourths. We're going to pretend they're all the same size. And I'm going to color in 1/4 of it. Now we are looking for 1/2 of 1/4. You can also say 1/4 of 1/2. I pick and choose. A lot of people want consistency. They want you to say 1/4 of 1/2 because that's how it's lined up. It's commutable. You can go both ways. So I'm going to go with 1/2 of 1/4. So now we look at our problem and we have 1/4 here. So I'm going to go ahead and divide it into halves. I'm going to divide the whole box into a half. Now I'm going to color in a half of that fourth. So now we look at it and say, okay, so what is 1/2 of that fourth? And we can see that it is one piece. And what is our new whole? We can't say it's 1/4 because our box is no longer cut into just fourths. Our box is now cut into eighths. So only one piece out of the eighth is worth 1/2 of the fourth. Does that make sense? This was our whole fourth, and we divided it into half. 1/2. Because that is what it was asking us to do by asking us to multiply it. Because when you have 3 times 2, you are saying, I need 3 2 times, or 3 groups of 2. 3 2 times. And it's the same thing with fractions. They just look more difficult. So you have 1/4, 1/2 of a time. So 1/2 of that fourth. Okay, I'm going to do another one. I love fractions. I find them fun. Okay, so let's do 3/5 times 2/3. This is going to be a messy picture, but we're going to go for it. I'm going to keep going with the box. But you can draw circles, you can do whatever you want. In a later manipulatives video, I'm going to show it with different shapes, but I'll go into that later. Right now I'm just going to draw a box. Okay, so I want to do 2/3 of 3/5. So I'm going to write that out. What is 2/3 of 3/5? So that means I'm going to go ahead and divide this into fifths. I don't know why I chose to do them this way this time. I don't know. When you understand the concept, it doesn't really matter, right? Okay, so I have my box divided into fifths. Now, I know that I need to color in 3 of them. So I'm going to go ahead and do that. 1/5, 2/5, 3/5. Or 3/5. Okay. So now we have 2/3 that we have to work with. So I'm going to go ahead and I'm going to divide this into 3 pieces, this whole box. I'm going to try my hardest. 1, 2, 3. Okay, so now this is in 3 supposed to be equal, sections. And now I know that I need to color in 2 of them. So we're ignoring the fifths that I did a while ago. We're only looking at the thirds that I just divided. So now I'm going to color in 2 of my thirds. So my thirds are going this way. So I'm going to go ahead and color in 1, 2. 2 of my thirds. So now you remember where they overlap is going to be your answer, because that is 2/3 of your 3/5. If you wanted to, as long as you understand that it's going to be out of 15, you can ignore this. What is 2/3 of 3/5? So we had 3/5 and we divided it into 2/3. So the 3/5 that we had is now divided into 2/3. So how many are overlapping? What is 2/3 of 3/5? So I'm going to go ahead and count them. I have 1, 2, 3, 4, 5, 6. 6 overlap. So that is my part. What is the whole now? Because I divided it into a bunch of new pieces. 1, 2, 3. 1, 2, 3, 4, 5. 3 times 5, I know that's 15. So 3/5 times 2/3 has to be 6/15. So let's do standard algorithm to make sure that we are right. Okay, so 3 times 2 gives us 6, and 5 times 3 gives us 15. So like I said, standard algorithm is pretty easy for multiplying fractions. It doesn't really tell you why it works. It doesn't really explain any conceptual things, kind of like the pictures do. But it is pretty simple once you learn how to do it.